exam, you obtain new expertise on SAP BTP. SAP experts will walk you through the content in a quicker and more efficient manner than the self-paced study, and provide you with an opportunity to engage and get answers to your questions either live through the main sessions or through the dedicated Ask the Expert session at the end. In the last session, we will be sharing more details on the free certification incentive, but you are also welcome to explore it yourself using the link that is provided in the slides. So, why to do the certification? Obviously, besides the new skill set and the knowledge that you will obtain through this academy, it's a huge benefit for you as an individual to get certified because it makes you objectively more attractive as an SAP consultant. A survey was done, and there are a few stats that you can see on this screen. The certified consultants are almost 90% more confident in their abilities as compared to a non-certified consultants. There is a higher job satisfaction rate. Also, the percentage increase in wage or promotion or job advancements increase exponentially once you get a SAP certification. Certifications also help your current employee as customers always prefer to work with knowledgeable and skilled partners. It's not just about doing the job, but doing the job right. So when it comes to SAP projects, customer usually prefer partners who have certified and qualified SAP consultants to manage the projects. SAP certification helps partners to demonstrate their skills in the latest SAP technologies and earn the trust of customers. Lastly, certified consultants are very important to SAP as it increases the project delivery success and reduce the project escalation. Apart from individual benefits, certifications are also important for the new partner competency framework. We have recently launched the new partner competency framework, which categorizes partners by the competency and specialization they offer in the market, giving customers transparency on their skills, expertise, and maturity as partners of SAP practice. It provides partners with a new branding logo and opportunity and plays a critical role in ensuring customers can find the right partners on the partner vendor app. As you can see on the slide, the number of certified consultants are a key are very important when you come for the partner competency. There are three levels. First is essential, then advanced, then expert, and the logo for each partner will be different. So while it is purely optional, it is strongly encouraged to complete your certification. Once this academy is completed, the steps are outlined in the next slide. So how does it work? The flow that we have envisioned is quite simple. Since you registered, you will be receiving invitations for 4 to 5 sessions that the academy consists of. The first for the first 3 sessions in this case that you will be considered as the main session, and the last session that will be there is an optional Ask to Expert session where me and my colleagues will be there to answer your questions, whatever you have from the complete learning journey set. These questions can be technical or theoretical, or it can be related to the certification exam. So after having the whole 3 sessions, you will obviously have a lot of questions, or if you have practiced on the system and you want to discuss something, we can connect over the last Ask the Expert session. Please note that the questions should be within the scope defined by the learning journey, and that cannot cover BTP questions beyond that. If any questions is not answered live on the session, we can follow it on later over emails. As a reminder, attending an academy should sufficiently prepare you for the associated certification exam. However, it remains attendees' responsibility to get familiar with all the learning jewelry content in order to pass the certification exam. So today we are here for the live sessions. After the academy will be completed by the end of this week, then we will be going for the Ask the Expert session. So this is a Learning Hub link, and this is the dates for all the sessions. So today is we are here. The next session is on Wednesday, then the next on Friday, and on November 22nd we have the Ask the Expert session. This is the certification code. If you want to know about more about the certification, you can click on this link. The slides and recordings for this session will automatically be distributed via email to all the participants in about 2 business days after the last session of this enablement series. However, since the Ask the Expert session happens typically uh, 10 days following the last content session, and we don't want you to have a delayed access to this content, we have provisioned a temporary share where you can access these files in typically 1 business days after each session. So like today's session you can access tomorrow. The link of this session we will be sharing in the chat. So please take a copy of it, and please note that this link expires on December 31st, 2022, and the password for accessing this folder will be BTP all small. So that was all about the certification exam and about the certification academy. So now we will be going forward with the technical content, and this is the agenda for today. So the first unit that we will be covering is the introduction, that will cover the overview of the Business Application Studio. The second unit that we'll be covering today is about the calculation views. That will be basically going with the basic concepts and the different types of calculation view. And the third unit that we will be covering today will be the different kind of notes that we used in the calculation views. And following will be the short recap and a Q&A. Please note that there are some knowledge quizzes that are defined as polls in this session. So after the completion of each unit, we will be going through with the polls, and I would encourage all of you to be participative, because your participation is a clear indication that if the topic that has been delivered is of like you have understood it or not, and also like that will make the session a bit interactive rather than just me speaking all the time. So now let's get started with the first unit. So the first unit for today is SAP Business Application Studio. As you might have received in the invitation links, there is a prereq to this unit, that is the introduction to HANA Cloud. So that was a prerequisite. I hope all of you have already covered that in the before coming to this session. So the first unit that we will be starting with is the SAP Business Application Studio. Here we will be looking at how we create a basic project in the Business Application Studio, also how we can import an existing project, or the normal design features of the Business Application Studio. So let's get started. So as you can see on my screen, this is the BTP trial account. I will also be sharing. Let me show you this on the system also. So if you can see on my screen, this is the BTP SAP BTP trial account homepage. The URL for it is .hanatrial.ondemand.com. So this is the HANA BTP cockpit homepage. I'll just refresh it. Yeah, so this is the BTP cockpit. If you want to access the business application studio, so the first way of doing it is the direct link, which is present here. If you click on it, the SAP Business Application Studio will open. The second way of doing it is to go to your trial account, and here we'll go to the sub account. Then going to instances and subscriptions. Here you can see that under the applications, SAP Business Application Studio is mentioned. So if you click on it, you can see that the business application studio opens up like this. This what you see here, first underscore app.sap, this is the space, and currently the status of it is stopped. Here if we click here, status will change to starting, and after starting in some time it will become running. Once the status is running, this link is enabled, and when we click on it, the business application studio opens. Please note that under the trial version, if any development space is not used for 30 days, it is deleted. If for the first time, if you are opening it, the button is provided in which you can create your own dev space. Like now, if you can see the status is running, so if we click here, the business application studio starts loading. And it opens. So you can see that there are a number of options here, and also there are a number of options here. So this is the introduction to the SAP Business Application Studio, how it looks like and how we open it. Now I'll go back to the slides. So once your BTP trial account is created, which is free, and information on the BTP account and sub account have been defined by you, you can start the Business Application Studio. So the slide shows the same steps that I have just demonstrated. So what is Business Application Studio? Business Application Studio is a development environment within business technology platform conceived for efficient development of business applications. Sorry. Just one note here. Historically, SAP HANA applications were developed using SAP Web IDE. SAP Business Application Studio is the next generation IDE. Web IDE for SAP HANA can also be used for modeling in SAP HANA Cloud, but it is not recommended as it misses many additional productivity aids and features that supports the modeler. Web IDE will not be developed further, and Business Application Studio will be the tool that receives all the new features. Business Application Studio is the recommended tool for data modeling in SAP HANA Cloud. So now we have created a few demo videos in which we will show you in practical the steps that are used while we create or import a project in SAP Business Application Studio. So now I'll be starting the demo. Please go through it, and let's start this.
In this demo, we will see how to import a project in SAP Business Application Studio. For this, we have to open the welcome screen and click on Files and Folders to open the project's workspace. We have to select projects here and click Open. Alternatively, we can go to Files and select Open Workspace and select the projects from there. Once the project workspace is open, we have to click on Import and select the required project file. We can select files with the extension .tar or .zip for importing a project. So the file is uploading. So the project has been imported. We can open it in a new workspace. So the project is open here and we can do the developments.
So this is the very easy method of importing a file. So the next demo video that we have is to work with the base features of Business Application Studio. Please note here that in the learning journey also, when you go through the content, these kind of simulations are present if you want to actually manually try doing it yourself. So these simulations are typically what we are showing you in this demo video. The steps are almost the same. So any thing that you see in these demo videos, if you want to experience it yourself, or if you want to try it in the system, you can go to the learning hub page, the learning journey, and then you can go to the unit, and then you can have the simulations. The detailed step of it, I will be guiding you in the sessions between the session itself, like how to go into the learning journey and how to do the simulations. So the next demo video is working with the base features of Business Application Studio. So here we will be looking at how are the different features available in the Business Application Studio.
In this demo, we will be working with the base features of SAP Business Application Studio. We have a project. If we drill down, we have the DB folder, and inside it there is a source folder in which we store all the database artifacts. We can create subfolders for storing different kind of data as I have created here. To upload a file, there are several options available. Firstly, we can drag and drop a file from the file explorer. Like we have a folder here, dataset. If I just drag it into the source folder, this will be uploaded. The second option is to upload it via right clicking on the source folder and going to upload files. We can also upload zip files. To unzip a zip file, we have to click on the file, go to in terminal, and the command unzip and the file name. So the folder is created here. We can delete the file like this. To create a database artifact, there are two options. First, we can go to View, Find command, and write artifact, and go to Create SAP HANA Database Artifact. We can choose the database artifact type. There are several options available. Here we will be selecting a HDB table. We can give the file name and click on Create. So we can see inside the data folder a table is created. We can add the definition here. The second option is to directly right click on the required folder and click New File and give the file name and the file extension. Like here we are creating a calculation view, so we will be giving the extension .htb calculation view. We can select the type and click create. So the artifact is created. So these were the basic features of Business Application Studio.
So these were the basic features of the Business Application Studio, how to create a file or how to create a database artifact, how the folder structures is organized, typically all these. With that, we commence the first unit here. It's time for the first poll. So basically, here we will be having a poll, and there will be two questions. So once you get the prompt, I would request all of you to answer the questions, and they will be. I will be waiting for typically 3 to 4 minutes, and then I will be discussing the right answers. So I will be launching the poll now. So there are two questions. First one is multiple choice with 4 right answers, and the second one is a single choice question. So I can see that almost everybody has participated. Thank you for your participation. And I can see that most of you have answered the questions correctly. So I will be ending the poll now, and let's see the right answers. So the first question was, which of the following ways you can use to transfer content between your computer and the development space in the Business Application Studio? So we can use typically all the ways, but deployment is not a way. Deployment is how we activate the file. So the last one is wrong. Apart from that, all the 4 is the right answers. The second one was the what is the recommended tool for data modeling, and the right answer is Business Application Studio. So that was all about the first unit. The second unit for today is the calculation views. In this unit, we will be understanding the One second. I'll just reconnect my mic if there is any voice issues. Is my voice any better, or is it still breaking?
Yeah, Nandita, let's continue and let's see in another 5 minutes if voice is okay.
Okay. I mean, I have reconnected my mic. So if it is still not, it's still not better, then I think I don't know. Okay. So let's start. In case the voice is still breaking, let me know, please. Okay. So the first topic of the second unit is the key vocabulary for modeling. So before starting on the concepts, there should be some terms that you everybody should be aware about their definitions. So we will be going through them one by one. So the first definitions that you should be knowing for that which is the basic concepts for HANA modeling are attributes and measures. So what are attributes? Attributes are something that are used to just a second. I'm just trying to reconnect my mic. So please, sorry for the inconvenience.
Hello. Is the voice quality better? I was saying that before starting with the key modeling concepts, we should be aware about some basic definitions that are used in the HANA calculation views. So the first definition is the attributes and measures. I'm quite sure that most of you will be already aware about these definitions, but I'm just going through them real quick. So at what are measures? So measures are numeric values that you can use measures are numeric values that you can use, such as the price or volume or the quantity. While attributes are things that are used to describe these measure amounts, and which we can use to filter or aggregate on the measures uh, in order to answer questions like, for example, what is the total sales of a particular region, or what is the total revenue generated by some specific product, for example. One key objective of modeling in SAP HANA Cloud is to create a relevant association between the attributes and measure to fulfill a particular reporting requirement. The next topic, sorry.
The next topic is the dimension and star schema. In some cases, analyzing the measures is easier if you group attributes together by dimension. In the example here, the sales organization would be treated as a dimension with the associated attributes like country and region. Similarly, a product dimension could be associated with several attributes such as product name, product category, or supplier. A star schema consists of one fact table that references one or several dimension tables. The fact table contains facts or measures as well as the keys used to identify for each dimension, which dimension members correspond to each fact. Each dimension consists of attributes such as name of the dimension member, description, and other attributes that can be used to filter the dimension members, build a hierarchy, and perform specific calculations. The next topic is hierarchy. A hierarchy is a structured representation of an organization, a list of products, the time dimension, and so on by levels. It is used to navigate easily the entire set of members, for example, the location of the company or the product or the days, months, weeks, or etc. When analyzing the data. The hierarchy concept, you see a geographical representation of the structure of the company by region or countries. The level of details of the hierarchy depend on how the company wants to analyze its data and its design too. For instance, the geographical hierarchy can be based on where the subsidiaries of the company are located. In this figure, hierarchy concept of the top node of the hierarchy group represents the entire. The next important one is semantics. So the term semantics is used to describe what a piece of data means or relates to. For example, a piece of numeric data that you report on can have different meanings. For example, a monetary value can be, for example, any monetary value can be the amount, while any number can be a quantity or a weight or volume or distance. So it can mean anything. Semantics mostly relates to the measure values. So these were the basic definitions that we are using in case of modeling in SAP HANA Cloud. So now let's start with the calculation. So what is meant by a calculation view? The definition, you can say that it is an object used in SAP HANA Cloud to build a virtual data model based on the data that resides in SAP HANA Cloud database. The purpose of a calculation view is to organize the data from the individual tables and to perform a variety of data calculations in order to get the relevant and meaningful set of measures and dimensions or attributes to fulfill a specific reporting need. The main benefits of using calculation views in SAP HANA Cloud are: firstly, no aggregates needs to be pre-calculated, and the front-end reporting tools delegate most of the data processing workload like filtering, aggregation, or calculations to the SAP HANA in-memory engines in order to achieve a very high performance. The second one is reusability. Each calculation view can be referenced by another calculation view. So in that way, we can typically reuse what we create in one view. The third is flexibility. Calculation views provide a number of features that make them very flexible. For example, we can define hierarchies, data filters, we can generate prompts for variables and input parameters, and we can also perform currency conversions. The last benefit is adaptability. SAP HANA calculation view can adapt its behavior to the list of columns that are selected or projected on top of it. For example, the rank node can be determined dynamically depending on whether the query result is done on one attribute or a group of attributes. So basically, there are two types of data reporting requirements. typically in any customer landscape. In the transactional applications such as SAP ERP, the underlying data which is stored in physical tables is generally handled by the application server. The application usually reads and writes to the database SAP HANA Cloud instance. The calculation views are used only to read data without making any changes to the SAP HANA Cloud database. So calculation views are typically used in analytical applications where we don't have to manipulate the data and we just have to read the data. Analytical applications that do not need to write to the database can bypass the application server and directly query the SAP HANA Cloud calculation views where data is calculated on the fly in the SAP HANA Cloud in-memory database. In SAP HANA Cloud, calculation view can exist in both as design time and runtime objects. The runtime views is a database catalog objects, more specifically a column view that is used when you open the data from the column view and or execute a SQL query or execute a query on top of the calculation view with external tools such as BI tool, Microsoft Excel and so on. When you deploy a source file with the Business Application Studio, SAP HANA Cloud creates a corresponding runtime object in the container, which is an abstraction layer of the database schema. This container is specific to the HDB module of your project. When building a calculation view, the SAP Business Application Studio allows you to use a feature called Data Preview to check the results. This simply launches the tool SAP HANA Database Explorer where your results are displayed. You can choose to view the default SQL code that generates the result. This is a simple SQL query that selects all the columns with no filters on the calculation view. You can also modify the query to remove columns or add filters, etc. in order to test the calculation view against different query conditions. SAP HANA DB Explorer is a web-based tool that we can basically not only use for data preview, but we can use it for multiple other things like browsing the database objects, executing SQL in the SQL console, importing or exporting data, creating and querying remote sources, debug, analyze and test SQL scripts, and also to use the trace files. So how to analyze data in a calculation view? Once the calculation view is created, we can typically analyze the data using two methods. The first one is the standard data preview, while the second one is the custom SQL query. Standard data preview, with the standard data preview, you can select all the columns that are included in the semantics of the calculation view, provided that they are not hidden. You can move the columns using drag and drop and apply temporary filters on one or several columns, and we can order the result by one or several columns. While in the custom SQL query, it is an alternate in which we can modify the default SQL statement corresponding to the data preview in an SQL console, and we can change the selected column or the group by clause. For example, if you do the standard data preview and then you go to the SQL that is generated and then you go to the edit SQL, and here you can modify it in the SQL console, and then if you do a run, then the results are shown in a custom query. So now the next topic is different type of calculation views. So in SAP HANA Cloud, three types of graphical calculation views are supported. First is the dimension type, then the cube type, and the third one is the cube with star join type. A dimension calculation views is used to expose the master data, and it cannot contain any measures. The default upper node for it is projection. A cube type calculation view consists of dimension as well as measures. The default node for it is aggregation. While the third type of view, which is a cube with star join type of view, it allows you to join dimensions calculation view with a star join node. So the default upper node for this kind of view is a star join. We will see in detail each type of view in the coming slides. So now let's move to a demo, and here we will see how to create a view of the type dimension.
To create a dimension type calculation view, we need to right click on the source folder, create a new file, give the file name and the extension .hdb calculation view. In the data category, we need to select dimension. In the projection node, we need to add the table on which we want to create the dimension type view. We can add any number of dimensions we want, but we cannot add any measures in the dimension type view. Any numeric value is also considered as a numeric dimension. We can create calculated columns and hierarchies. We can also create input parameters if we want to filter the data. For deployment, we need to save the view and click Deploy button. For data preview, we need to right click on the view and click Data Preview. The output is presented like this.
So this is how we create a basic dimension type calculation view. So the next one is how to create a cube type calculation view. When you want to create a view that includes measures, you use a calculation view of the type cube. By default, the result of this type of view will always be aggregated by the attributes requested by the external query. So even though the calculation view may be able to provide many attributes and measures, the measures are automatically aggregated by the attributes that are requested by the query. This behavior is different to the SQL access only calculation view type. This type of calculation view is optimized for OLAP style analysis, where the slice and dice is required over the measures by any combination of attributes within the model. A cube calculation view does not allow dimensions based on dimension type calculation view to be included. All attributes used in analysis come from within the defined model. If you see the steps, basically the steps are same, but the data category we select while creating a new calculation view is of the type cube. And then we add the required attributes and then we deploy. The third type of view that we create is the cube calculation view with star join. An extension to the basic cube type calculation view, the cube is the cube view with star join. In addition to the capabilities of the cube type of calculation view, a cube with star join calculation view allows you to join dimension calculation views to the basic model in order to extend the analysis capability. So a star join node enables you to join the fact data with the descriptive data. The input allowed to the star join node includes the all the lower node and the relevant calculation views of the type dimensions. During the deployment, the start join node is always deployed with an aggregation node on top of it. The start join node is deployed first and then the series of joins and then the aggregation logic is deployed. This allows the view to aggregate the measures dynamically based on the attributes columns that are included in the result set. As already said, in addition to the fact data source or the fact table, the only other possible sources of start join node are calculation views of the type dimension. But dimension views can also be used in a classical calculation view without start join if relevant. So the basics are same here, and we will see more of it in when we will see the demos. So what are the supported data source types in the graphical calculation views? If you see this slide, the source of data that we are using inside the calculation view can come from two sources. Either it can be located in the same database as the calculation view, or it can be located in another database in the same multi-tenant system. So the different data source types such as row table, column table, SQL views, graphical calculation views, table functions, or virtual tables, if located in the same database, all these data types are supported. While if they are located in another database, table functions are not supported. Rest all of the table types are supported. To understand if we see here that there are two types of tables mentioned, row table and column table. So to identify whether an existing table in SAP HANA is a row table or a column table, we have two options. Firstly, we can explore this from the database explorer, which is connected to the HDI container or the catalog view of the standard schema. For a table, we just need to check the table icon. If we click on it and open its definition, then in the table field type, it is mentioned that if it is a row table or a column table. The second one is using the SQL console. You can just query the system table m_tables, and if you in the where condition, if you write the table name, in the properties you will see that it has the table type mentioned, for which can be a row table or a column table. So let's see more details about the dimension calculation view. Dimension calculation views are typically used to provide context, and the context is provided by master data tables, which give meaning to the data. For example, if the data in the car sales database only contains numeric ID for each dealer, you can use a dimension calculation view to provide information about each dealer. Using this method, you could then display the names and addresses of the car dealers and many other useful descriptive attributes that give context to the data. Dimension calculation views are used to select a subset of columns and rows from master data tables. Dimension calculation views are not valid for measures. They can contain only attributes. Dimension calculation views are used to select a subset of columns and rows from master data tables. Dimension calculation views are not valid for measures. They can contain only attributes. A dimension calculation view does not need to be based on a single table. On the contrary, you can use them to join master data tables to each other and create complex views. Dimension calculation views are reusable objects and they can be shared between different cube type calculation views. For example, if we create one dimension calculation view for product, it can be used in several cube calculation views like purchase order or sales order, in which we need multiple attributes from the product master data. Dimension calculation views support most type of nodes. such as projection, join, union, aggregation, or ranking. This allows a very flexible design of dimension calculation views. The most commonly used nodes are join nodes and projection nodes. Apart from the standard fields that are coming from the base tables, it is possible to create additional calculated columns in the dimension type calculation views. For example, if you have two columns containing the first name and last name of the customer, but you like to have all this information in a single column, you can do that by creating a calculated column based on string manipulations. The calculation can be arithmetic or just a character string manipulation. Calculated columns are also support non-measure attributes as part of the calculation, and it is possible to nest calculated column. That means you can use one calculated column in turn inside another calculated column. So typically calculated columns are used if you want to create another column which are typically not present in the base table, but it can be derived from the base table. The next important topic is time-based calculation views. In addition to the standard type of calculation view, the time type is used to create dimension calculation view that can apply on time data. The purpose of these time-based dimension calculation views is to provide additional date time attributes that expand the navigational possibilities. For example, by deriving the week number or the fiscal period from the date column. So you can use the time-based dimension calculation view to build a time hierarchy that corresponds to your reporting need and convert a timestamp into simpler attributes such as year, month, or day of the week. One key benefit of using a time-based dimension calculation view is that you can easily summarize the data that the calculation view exposes. For example, based on the daily data, you can choose to retrieve summarized or aggregated data by calendar week or by month quarter, or provide a drill down from year to half year to quarter to month to week to date. So basically, if we use a time type calculation view, we linked it to a timetable and then we get a lot of time attributes. There are different type of calendars available in the time calculation views. One is Georgian. In the Georgian calendar, it is made up of year, months, and days. The level of granularity here can be down to hours, minute, or second. The second one is the fiscal calendar. The fiscal calendar is organized into fiscal years and fiscal periods. Several fiscal year variants can be defined depending on your reporting needs. In the cube type, as compared with attributes, measures bring an additional level of complexity to the calculation views. In particular, you must define the relevant behavior of the views when measures are aggregated based on number of attributes. In the SAP HANA Cloud, two types of graphical modeling objects handle the measures. The first one is the calculation views of the type cube, while the second one is the cube type with star join. In a calculation view, the measures can have origin from several data sources, that is several tables, calculation views, table functions, and so on. For example, you can join two different tables and extract measures from both of them. So now that we have known many elements, we are ready to see a demo on how to create calculation views of the type cube.
To create a basic cube type calculation view, we need to right click on the folder, create a new file, give the view name, and the extension .hdb calculation view. In the data category, we need to select cube. In the aggregation node, we need to add the table and click finish. We can add the required dimensions and the measures from here. In the semantic node, we need to check that the dimensions and the measures are selected correctly. If not, we can change. We can create calculated columns and restricted columns here. We can create hierarchies and input parameters to filter the data. To save, we need to go to Files and click Save or Ctrl+S key. For deployment, we need to click here. After the file is deployed, for data preview, we need to right click and go to data preview. The output is presented like this.
So this is how we create a cube type calculation view. Now let's see some common features to design calculation views. Semantic types for attributes can be defined as the list above. The semantic type for attributes can be currency codes, unit of measures, date. It can be a date from, date to, or it can be geographical attributes like longitude, latitude, or Carto ID or normalized names. It can be a hyperlink too. For measures, the semantic values can be only to a amount with a currency code or a quantity with a unit of measures. Other important settings that can be defined for each columns are assigning a description to another column, hiding a column, or assigning a variable. Assigning a descriptive column to another column, for example, if we have a column with the product ID, we can define a label column to it that will have the product name. Or if we have a column with employee ID, we can have a label column to the same column that will have the employee name. The hiding a column means that if we have a column in our semantic layer that we don't have to show in the report output, we can hide that column altogether. Also, assigning a variable means allowing the user to select a filter value at runtime for that specific attribute. Each calculation view has a semantic node on the top where is assigned a meaning to each of the column. So the semantic tab is the last tab when we define a calculation view. In the semantic node, you can define and review the properties against assigned to the columns that are in the output of the top node. The typical properties that you see here are the aggregation type, conversion functions, if we have using any data masking, the data type, a label column, or if the column is hidden or not. Please note that this list is not exhaustive and there are many more. If you see in the system, you can see all of the list that is available. You can choose to hide the attributes that are not required for client consumption. This typically occurs in the following scenarios. When an attribute column is calculated using complex computation of a source column or intermediate calculated columns, you can hide any column that you don't want to expose to the end user. When a column that contains a description has been assigned to the corresponding code, name or ID column as label column, you can hide the text column. This action is particularly useful in scenarios where the reporting tools are able to interpret this code, name, ID, description, assignment. The next topic for this unit is sorting the result dataset. SAP HANA Cloud provides with the possibility to sort the result set of any calculation view. This enables to define a sort order that will apply when none is specified by the client query that is executed on top of the calculation view, thus guaranteeing a stable result order. It can also be useful when previewing the data for the purpose of testing your calculation view. So we have two options here. The first option is in the semantic node, open the columns tab, and in the columns tab, select the sort direction using the drop-down selector against any of the column, like this. So here you can see that we have two options, ascending and descending. In case you want to specify more than one columns are taken into consideration in order you define them. The second option is in the semantic node, open the columns tab and then select the sort icon to open the sort result set dialog box. Okay. So if we open that, then add a new row, then we can add multiple columns and we can select the sort action. The next feature in the semantic node is hiding the column. As you can see here, there is a checkbox that says hide columns. So if we select this checkbox, these columns will not be exposed to the client consumption, but it can be still used to have the calculated columns. Sometimes in columns, both attributes and measure can contain undefined values or null values. You can handle such cases by defining default values that replaces the null values in the reporting tools. This is done by replacing the column values that would usually appear with null value representation like a question mark with a default value null, empty, or with any other user defined value. We can do this using the following steps. In the semantic node, go to the columns tab. In the column tab, select the measure or attribute and then select the null handling checkbox. In that, we can give a default values in case there is a null value appearing. For columns of the data type and varchar, if you have not defined a default value after enabling the null handling, the tool displays an empty string, which means a default value. Apart from the semantic node, the next important thing in the top node is the view properties. For each view, you can define a number of properties in the view properties tab of the semantic node. Depending on the type of view, the list of available properties may vary. Calculation view properties are organized into two tabs in the semantic node that have the labels General and Advanced. Specific features to enhance flexibility of calculation view design, because calculation view offer a lot of flexibility, in particular the possibility to have large number of nodes in a view. The SAP Business Application Studio provides advanced functionality to manage nodes and semantics. So you can see the list here. In general, we have the data category, default client, default member, etc. While in the advanced, the properties are like the pruning table configurations, or if we have to execute, then which engine we should execute in, or if we want to have cache or execution hints. So these are the advanced properties, while these are the general properties. Apart from this, inside the calculation view, there are several other features also, interesting features. Like we can switch the node types. For example, we can switch one node type with another without losing the link to the data source in the upper or lower nodes. The second interesting property of a calculation view is the replacement of a data source. For example, if we have created a data source and we want to replace the table or the view with another table of view, it is possible without changing the upper nodes. The third interesting property that is present in the calculation view is propagate to semantics. So if we have to add inside a pre-existing calculation view, if we want to add another column, so we can directly add that column and click propagate to semantics. It will directly move up to the semantic node. Another interesting property that we have in the calculation view is the data preview on the intermediate nodes. So basically, apart from the top data preview, we can do the data preview at the any of the intermediate node level. This enables intermediate data sets that are typically used when we are testing the calculation view results. Another interesting property of calculation view is the mapping input parameters between the nodes. So if we have an input parameter defined in any of the underlying views that are used in another calculation view, we can map the input parameters so that the filter values or the parameter values are passed on inside the another calculation view. If we have created a calculation view and we want to know that a field that is displayed in the calculation view is coming from which data source, we use the feature called the column lineage. The show lineage functionality enables the tracking or the origin of the column along the calculation scenario down to the first node where it appears. This node can be the bottom level node of the view where the column is selected from the source, such as another informative view or a column table. It can also be an intermediate node where the column is calculated. The show lineage is a great feature for locating the origin of column that might have been renamed during the flow. For getting the lineage, we have to just right click on, we have to select the column and then we have to click on show lineage, this button. With this, we are almost at the end of this second unit. So here in this unit, we basically analyzed what are the different type of calculation views and what are the different features of the calculation views, different properties that are used inside the calculation view. We have still not gone through the detail of each node, different type of nodes that are available, that we will be going on with the next unit. But in this unit, we went through the different properties that are available and the different types of calculation views. So this is the end of the second unit. Now we will be going to the second poll for today. This poll will have 4 questions, and I will be opening this poll for another 3 to 4 minutes. I would request all of you to mark your answer as soon as possible. Please note that this one also is a multiple choice and single choice combination. So there will be 4 questions. 2 are multiple choice and 2 are single choice. Please mark your answers accordingly. So I have launched the poll now.
We encourage participants to mark the answers. So currently, just 30% of you have replied to the polls. So please take this opportunity and mark your answers.
So the final 1 minute, I will be closing the poll shortly. Please mark your answers and then we will be discussing the right answers. So I will be ending the poll now. Let's see the right answers. So the first question was, which are the supported data source types in the calculation views? So data types, apart from the flat file, all the other fours can be used as the data source inside the calculation views. Second one, which of the function of aggregation node in the graphical calculation view that is used to control the aggregation. The third question is, which of the following are types of calculation views? So this is basic one. The right answers is a dimension, a cube, and cube with star joint type. And the fourth question was, why do you hide columns in a dimension calculation view? The right answer is when you want to hide a column which is not allowed or required for client consumption. So these were the right answers. Thank you very much for participating. So now let's take a 10 minutes break. And after 10 minutes, we will be joining again to start with the third and final unit for today. And in the third unit, we will be going through how to use different nodes inside the calculation. So let's reconnect after 10 minutes.
hàng fresh, hàng chế biến gì mà tồn cả tháng rồi, còn là sao? Còn không thì xuất thủy dùng trên hệ thống đi chứ. Em họ ở đâu vậy? Em hỏi chị Nhân không mua. Có cái group nào mà chị Lưu chị Hậu vô vậy? Chị nhắn trên sách lót. Nhưng mà sách lót có quá nhiều người, quá nhiều cái điểm cần trao đổi đây này, nó rất là loạn.
Vô sâu rồi mấy cái bạn vô sâu giờ ai tư dụng ký hết rồi phải thôi
Không, trước khi chị nói sắp Tết thì cái vụ cái nào đang control chuyện kho không có tồn đúng không? Chắc neo lại để bên phía cái tháng bên kia là có cho phép không chị? Nhưng mà giả bộ nó bằng không.
So hi everybody, I'm back. We will be starting now with the third unit. I hope all of you are back with your cup of coffees. I This unit is all about the different nodes that we are using inside the calculation views. So here we will be working through nodes like union, minus, rank, join nodes, different kind of joins, etc. So inside a calculation view, we use different kind of node types to perform different kind of operations. Depending on the requirement need, there can be different types of nodes that are used inside a calculation view. Typically, these are the kind of nodes that we see inside the calculation view. The first one is a projection node. Then we have join nodes. We have union, minus or intersect nodes. We have aggregation nodes and ranking nodes. Apart from that, if you see when you create a calculation view, total we see these kind of node options available. Let's see a simple business case. For example, if we have three tables, sales order, customer and state, you can see that these three tables have different kind of data. The definition of a join is a view that combines two data from two or more sources having some columns in column. For each join node, you must define which columns of the two joined sources must participate in the join, as well as the join type. You can also specify the cardinality with the help of the proposed cardinality feature. To begin with, in this data set, you can make the following observations. Sales order 8 does not have a customer master record. Customer Tom does not have orders. The state TX does not have a description, while no customer resides in Alabama. So all these three data sets are interrelated, but right now they are in different tables. So now let's see a demo in which we will use a simple join node inside a calculation view and we'll see its basic features. Please note that the sample data set that I just showed in the last slide, it is not used in the demo, but we have used some different data set. But in the coming slides, when I will be showing you some description against different kind of nodes, we will be using the data set that is in the slides.
To create a join, we need to click on the join node and add the join. Here we have already created a cube type view and added two projections with two data sets that we need to join. We need to connect both projections with the join node and open the dataset like this. In the join definition, we need to add the appropriate joining columns with each other. As we can see, the various join types that can be added here are referential, inner, left outer, right outer, full outer and text joins. We can also change the cardinality of the data if known. Then we have to go to the mapping and select the appropriate columns that are required for the output. Here we have added the title and description based on the book ID. We can create calculated columns and parameters here. Then we have to join the join node to the aggregation node, add the required fields in the output, go to semantics check the type and correct if required, and save and deploy. After deployment, we can preview the data. As we can see, the columns description and title are populated based on the book ID.
So here we joined two tables and we populated some columns from the second table. So this is a typical example how we create joins. Now let's see how are the different type of joins available in the HANA models. So these are the list of the different type of joins that are available. It's very similar to what we typically do in any DB system. So the type of joins are inner, left outer, right outer, full outer, referential, text, temporal, and spatial. The inner and outer joins are similar to the other database management system. All the others are specific to SAP HANA. The temporal join is an inner join to which you add time-related conditions. Temporal joins are only supported in the star join of calculation views of the type cube with star join. The join type must be defined as inner. The referential join implements the concept of referential integrity between two tables. That is in the joined columns. Integrity more columns integrity between two tables that are joined. There is always a match in the right table for a row in the left table, or the other way around. Or we will go in detail in each type of join type in the coming slides. So the first one is the inner join. The inner join is the most basic of the join types. It returns rows when there is at least one match on both sides of the join. On the left side, we can see an inner join in the dimension calculation view, while on the right side, we are inner join in a cube type calculation view. So if you see here, if we join the two tables, customer and state, only the column data which is common to both is projected here. Similarly, here if we join the customer and the state data and the sales order data, only out of the three, the rows which are common to all three of them are populated. The next type of join is the left outer join. A left outer join returns all the rows from the left table even if there are no matches in the right table, where a design time filter has been put on the state. The figure on the right shows the left outer join on a cube type, while it is this one is the one that is done on the dimension type. So here basically everything on the left comes in and only the matching column from the right comes in. The right outer join is opposite of the left outer join. So here it typically returns every row from the right table even if there is no matching data on the left table. Here you can see in the dimension type example, all the state data is populated even if no customer resides in Alabama. And similarly here, all the state data is populated while only the matching columns from the sales order and the customer tables are populated. Then comes the full outer join. A full outer join combines the behavior of the left and the right outer joins. The result set is composed of the following rows. Rows from both table that match on the joined columns, rows from both left table that have no match on the right table, and join data from the right table that has no match on the left table. A full outer join is supported by calculation views only in the standard join and the star join views. However, in the star join node with a full outer join can be defined only on one dimension calculation view, and this view must appear last in the star join. The next type of join that we are going to see is the referential join. SAP HANA Cloud offers a type of join that is optimized for performance. The referential join is based on referential integrity. The concept of referential integrity between two tables A and B means that in the joined columns, one or more columns from each table, there is always a match in the table B for a row in a column A and the other way around, or it is optimized for performance. It means that the referential join is not executed in circumstances where the result will be same as if the join was executed. It operates like an inner join when the join is executed. In other words, when a referential join is not pruned, it is executed as an inner join. To define a referential join, you first add a node to the calculation view scenario and assign two or more data sources. In the case of a cube with star join calculation view, you assign a lower node to the star join node and add one or more dimension calculation view. Then you have to define the following settings. Join type, this setting must be set to differential, this one. Then the cardinality, this must be specified. If it is not specified, differential join will not be optimized. Then the integrity constraint, this second setting defines in which direction the differential integrity is guaranteed. The possible values is left, right and both. Left means every entry in the left table has at least one match in the right table. Right means every entry in the right table has at least one match in the left table. And both means every entry in both table has at least one match in the other table. With the integrity constraint setting, you ensure that the optimization of the join occurs only when it is actually possible, because the cardinality alone is not enough. If integrity constraint is set to left, no join optimization is triggered if the query requests any columns from the right table. The next type of join is a text join. Text join enable SAP HANA Cloud to handle the translation of attribute labels in a way that corresponds to how translation texts are stored in the master data. Technically, a text join behaves like a left outer join with cardinality 1:1. But in addition, you specify a language column, typically called SPRAS in SAP system tables. During join execution, the language of the end user querying the calculation view is used to retrieve descriptions from the text table in the corresponding language based on the language column. The second, in the second figure shown on the right, it's a simplified example of a text join. Depending on the session language of the end user, the DESC column displays the product description in either English or German. So if the SPRAS is selected as E, the values will be shown in English, while if it is selected as D, it will be shown as in German. So the language column is specified here if we see the join type as text. During the join execution, the language of the end user querying the calculation view is used to retrieve description from the text table. So basically, text join is normally used when we join the master data tables in the calculation view where we retrieve the descriptions. The next type of join that we will be discussing here is the temporal join. It is possible to add temporal conditions to a join in order to find matching records from two tables based on a date. The records are matched only if a date column in one table is within the time interval defined by the two other columns in the other table. Temporal joins are only supported in the star join of calculation views of the type cube with star join. The join type must be defined as inner Temporal conditions can be defined on columns of the type timestamp, date, or integer. So here if you see, the sales order table has a column date, while the customer status table has two columns, date from and date to. So if we define a temporal join, then any date that is lying between the from and to dates will be picked and the records will be joined accordingly. The next is a star join. The star join, it is used to structure data in the star schema. The fact table or the data source of the star join can be any type of input node. However, only calculation views of the data category dimension are allowed as input nodes for dimensions. In a cube with star join calculation view, the columns tab of the semantic separates the column into two categories. One is private columns. These are the columns that are defined inside the calculation view itself. And the other type is shared columns. Shared columns are the columns that are defined externally in one or more of the dimension calculation view that are referenced by your cube with star join. On these shared with the other cube, you can still hide some of the columns to keep the ones that you need. Regarding the shared columns, their name, label, properties cannot be changed as compared with a private column, but you can define an alias name and an alias label if required. The next topic that we are going to discuss is not a join type, but a join property. This is the join cardinality. The cardinality of a join defines how the data from two tables joined together are related in terms of matching rows. For example, if you join the sales order table, the left table, with the customer table, that is the right table, you can define a n:1 cardinality. This cardinality means that several sales orders can be related to the same customer. But the opposite is not possible. That is, you cannot have a sales order that relates to several customers. This analysis of join tables is performed at the moment you define the join, but content of the tables evolves after that. The cardinality that you have defined might become incorrect. So basically, cardinality is the numeric relationship between rows of two tables. The possible values can be n:1, 1:n, n:m, or 1:1. We should always do the cardinality, define the cardinality only when we are sure about if the data that resides inside the tables are correct or it is not a test data. There is a button called the propose cardinality button. So the propose cardinality button typically is used if we are using two tables, and it can analyze the data set and it can propose that this data is of this cardinality. The next type of join which is used is a very different kind of join, which is the non-equi join. SAP HANA Clouds provide a kind of join called a non-equi join, where the join conditions is not represented by an equal operator. For example, the value of column customer ID in the table orders equals the value of column ID in the table customers, but instead is based on other comparison operator such as greater than, less than, etc. This new type of join allows more flexible conditions to address specific scenarios. The objective is to display in a calculation view which subtask will not be finished early enough to allow a company to meet the planned completion date for some products. This requirement can be achieved with a non-equi join with the following join conditions. First, like in this case, we can define it as the ID is equals subtask ID, and the due on date should be less than the planned date. If we define like that, then this requirement will be fulfilled. Basically, once you define a non-equi join, the operators that can be defined are selected here: less than, greater than, or greater than, equal to, less than, equal to, etc. This is a very interesting kind of a join. Typically, it is not that much used in the scenario, but using this kind of join, we can actually fulfill a lot of complex reporting scenarios. The next type of join is also a non-typical join. It is a multi-join. SAP HANA Cloud provides new capabilities in join nodes, which is to allow more than two data sources in the same node. When more than two data sources, for example, tables, other calculation views, or other nodes are assigned to a join node, you must define a priority or precedence for join execution. This is done in the Properties pane of the Join Definition tab. You need to specify the following: the multi-join order, which is mentioned here, and the central table, which will be the central table for this join execution. I mean, the multi-join will start from this table. The order of join execution can have following values. The first one is inside out, the second one is outside in. When we are doing a outside out, the furthermost join from the central table will be executed first, and then it will be executed towards the central table. While in the inside out, the join which is like the first join to the central table is executed first, and then it is executed in the opposite order from inside to outside. With more than two data sources feeding a join node, the results sometimes depend on the join execution order, but it is not always the case. For example, when all the joins are inner join, the result set generally is the same regardless of the join execution order. With a mix of inner and left outer joins, the result set will vary if we change the join execution order. The next type of join that we are going to discuss is a dynamic join. In some scenarios, you want to allow data analysis at different levels of granularity with the same calculation view. This is generally possible in an aggregation node when measures support the aggregation at different levels. In the figure, you can see dynamic join shows an example of a more complex scenario where you want to present two different measures side by side, either by country or region: the sales by product and the total sales of all products. In this case, assuming that your model, you model your calculation view with a regular join on country and region, you will get inconsistent, you will get correct results if you analyze the data by country, but the results will be inconsistent if you analyze your data by region. Pay attention that with the dynamic join, if none of the joined columns are requested by the client query, you get a query runtime error. If we consider the join behavior of the join from an aggregation perspective, in a regular or static join, the aggregation is executed after the join. In a dynamic join, when a join column is not requested by the client query, an aggregation is triggered to remove this column, and then the join is executed based on only the requested column. As in the dynamic join, only the join column requested by the query play a part in the join execution. The same calculation view can be used for both purposes if we want to analyze the data by country or by region. The next topic for today is join column optimization. Compared with an inner join, a differential join can be omitted in some circumstances without affecting the calculation view output. Per default, the field on which the join is defined will be requested during the query processing, regardless of whether the field is necessary from the query output or not. The key objective is to guarantee a consistent aggregation behavior concerning the joined field even when the field is not requested by the query. So for the join column optimization, this is a checkbox. You will see it in the join properties. If we check this box, then pruning occurs when all the four of the following condition is met. The first one is the join type should be referential, outer or text. Basically, it doesn't work if the join type is inner. But if it is referential, outer or text, then the joining columns can be optimized. The second condition is that columns from only one table is requested. The third condition is that the joining column from A is not requested by the query. For example, if we are joining table A to B, it will be joined using some column, right? So in the output, columns from only table A are requested and the joining column is not requested. And the last condition that we have to take care is that the cardinality of the side B, which is the joining table, is 1. For example, either it is 1:1 or n:1. So if all these four conditions are met and the optimized join column is written, then when the join will be executed, then it will be performance optimized. So this was all about the join nodes, different kind of node joins that we can use. The next topic that we are going to discuss is the another type of node, which is a union node. A union node is used to combine two or more data sets to a common set of columns. A mapping of the source to the target is required, and this can be done via a drag and drop interface. Depending on how different the column names are from the data source, the mapping can be done automatically by name if the names are identical, or define the mapping manually. A standard union is where for each target column in the union, there is always one source column that is mapped. In the example, you see both sources provide a mapping column to the union. The source column does not have to have the same name as the target column. For example, a source column of month can be mapped to a target column period. So semantically it should mean the same, but technically it can have different names. A union with constant value is where you provide a fixed value that is used to fill a target column where the data source cannot provide a mapped column. For example, you have a data source that provides the actual amount, and you also have a second data source that provides the planned amount. You decide to avoid combining these two measures into one column as they would lose their meaning, as there is no attribute to describe the meaning. In this case, you would map the measure to a separate target column and provide a constant value 0 to the target column of the missing measure on each side. The choice between standard union and a union with constant value depends on the data that you are using and the way you want the end users to report on the data. If it is more beneficial to present different measures in different columns, you can use union with the constant values so that you define a way to provide a value, probably 0, to a column where there is no source mapping. On the contrary, if it is easier to present measures in a single column and differentiate between them using an attribute such as amount type, then we use a standard union. So if you can see in this example, we have two tables. One is having an actual amount while other is having the planned amount. So if we use the standard, then we have to an attribute column that will differentiate between the actual and planned values. So here the actual will have a flag value A, while the planned will have the flag value P. In this case, if we do the union and join customer to customer, amount to amount and flag, then in the output we will see that we have only 3 columns and the flag value and the aggregated values. So if we filter on A, then we get actual values, while if we filter on B, we get the planned values. The second scenario is where we don't have any flag columns or attribute columns that differentiate between two data. In this scenario, what we will do, we will use union with constant values. Here, we will define amount, one as amount underscore A, which is the actual amount, and the second one as amount underscore P, which will be the planned amount. And then we will join customer to customer and amount to amount. In this case, then we will join customer to customer, and then we will add amount underscore P and amount underscore A as separate columns. That union with constant values. So as you can see that amount underscore P will not have any value in the second the B table, while amount underscore A will not have any measure values in the calculation view A. So we will add constant value 0 so that we have different columns and we will be having the same result output as we had here after aggregation. So the output is the same. The only way why we use these two kind of union nodes is depending on the reporting requirement. If you have to report on separate columns, then you define like the second option. If you have only one output as the final output measure column, then you use the first one. So it's typically pretty much need based. So now let us see a demo video that will show how to create a union node in the Business Application Studio.
To demonstrate a union, we have created a calculation view and added two projections. First, having data before 2020 and second, having data after 2020. To add a union, we add the union node and map both the projections to the union. We use union when we have to combine two similar data sets into a single result set. We can map the columns in two ways. First, we can drag and drop and map each column. Second, if the name of the columns are same, then we can use the feature auto map by name. As we can see, there is an extra column here in the first projection which is not present in the second projection. For this, we can right click, go to manage mapping, and we can add a constant value against the second projection. Then we'll propagate the values to semantics. Check the dimensionality and deploy. Let's see the data preview. If we add the year and the quantity, we can see that the data is present for both the subsets. Also, if we add the flag, we can see that the constant value are correctly maintained.
So this is a simple demo in which we saw that how to create a union using both the type of solutions. So now let's see a comparison between join versus union all. When to use what? When you need to combine measures originating from more than one table or calculation view, you might want to create a join between these tables. However, under most circumstances, you must avoid using a join to address this requirement because it is very costly from computation standpoint. It is more beneficial to use a union node which provides much better performance. Technically, a union is not a join type. Furthermore, a union node generates a list of all values from input data sources even if the values are repeated. For example, if two data sources both include the same customer, then the customer will appear twice in the output data set. If repeating values are not required, then you should include an aggregation node on top of the union node to aggregate the columns. We normally associate aggregation behavior with measures such as sum or average, etc. But aggregation can also be performed on attributes. The effect of aggregating attributes is to simply produce a distinct list of values. So for example, if you see, if we have two tables, one is having mouse and keyboard data while other is having mouse and camera. So if we even it will generate attributes which are repeating, like mouse will do two times. So if we have an aggregation node on top of it, then it will aggregate the attribute to produce a list of distinct values. The next kind of node that we are going to discuss is an intersect node, intersect and minus node. SAP HANA Cloud provides different kind of nodes dedicated to set operation. These are intersect and minus. Intersect filters members that belongs to the two data sets, while minus filters the members that belong to one data set and not the other. You see that intersect is symmetrical, that is, it gives the same result regardless of the order of the two data sources, while minus is not. In this example, if you see that we have two customer groups, one is having dataset 1, 2, 6, 5 and 7, while other is having dataset customer 3, 4 and 5 and 7. So if we use intersect, it will only give you customer 7 and 5. While if we use minus, then it will give you a different result if you do A minus B or if you do B minus A. So basically, intersect is symmetrical because it will give you a common values which is common to both. While if you see minus, it will give you the customers which are present in the set A, but minus the customer that are present in the set B. Like if we do minus B, it will only give you 1 and 6. While if we do B minus A, it will give you 3. So you can use intersect and minus nodes if you have a reporting requirement that has similar kind of output required. It is possible to change the order of the data sources. Just right click on the minus node and there is an option of switching the order. If you switch the order, then it will automatically make the right table left and left table right. So this was the next set of nodes which are intersect and minus nodes. Now we will go to the most common nodes which is typically present in every cube type view, which is the aggregation node. The purpose of an aggregation node is to apply aggregate functions to the measures based on one or several attributes. This function acts similarly to a group by clause in the SQL query, where you must specify the aggregate function for each measure. A graphical calculation view can support different type of aggregations such as sum, min, max, and count. When adding a column to the output of an aggregation node, you define whether the column is used for grouping or if it must be combined with an aggregation function such as the aggregated out column. In the second case, you must specify the aggregate function to apply. Sum is defined by default, but you can add different aggregation functions like min and max also. When you work with aggregation nodes, the list of columns requested by the client query can influence the way the aggregation is executed, especially in complex scenarios. The following features can help you control the aggregation of measures in order to build a more flexible model. The two important features inside the aggregation node are keep flag and transparent filters. If you select keep flag, then if this filter is set to true for a column, it forces the calculation to be triggered at the relevant level of granularity. While if we select transparent filter to true for all the nodes using the customer column, we stop the customer column from being used in the group by clause. So basically, keep flag and transparent flag are opposite of each other. If we want that no matter the column is selected or it is not selected, but that column should always be there in the group by clause, then we for the specific column we select the keep flag as true. While if we want any column to not present at all in the group by clause, we select the transparent filter. Then in that case, the column will not be used in the group by filter, even if it is added in the column. So these are the two very important properties of the calculated aggregation node. The next important node type that we are going to discuss is the rank node. The purpose of a rank node is to enable the selection within a data set of the top or bottom n values for a defined measure and to output these measures together with the corresponding attribute and if needed another measures. The SAP HANA Cloud provides more advanced capabilities for the rank nodes compared with the previous versions. In particular, it implements several ways to define the number of return rows for each partition by combining the aggregation functions, result set type, target value, and offset. The picture here describes the flow as the system operates on the ranking. The first one is the logical partition. So whatever columns we add here in the logical partition, the data will be grouped by these columns and then the individual ranking will be applied. Then here we can use multiple columns. Then if we select multiple columns here, then the data will be grouped with all those columns and then the ranking will be applied to the individual groups. The second one is choosing the aggregation functions. The rank node offers four kind of aggregation functions that can be classified into two categories. The first are for computing the row numbers. These three options that can be present are here in the aggregation function. It can be row, rank, dense rank, these three. And the one function for computing the values of sorted columns is the sum. So total we have four kind of values present here. The first one is be row and then rank, dense rank and sum. Normally we use rank or row. Other important ones are if we want to have another specific column for the rank number, we checkbox called the generate rank column. And also if we have any columns on which the result should be pre-sorted before we apply the rank, then we add the value here. And also if we want like the top 5 or the top 10 or any, if the n value is fixed, then we have the number that can be added in the target value. So these are the main settings of the rank node. Basically, we have the logical partition. Logical partition defines the source data set by one or several columns before executing the rank computation. The rank data set can be partitioned by one or several columns. The second important one is the aggregate functions. The rank node offers four kind of aggregation functions: row, rank, dense rank, and sum. While the row, rank, and dense rank are used for computing the row numbers, the sum function is used for computing the values of a sorted column. The result set type the result set type is if we want to work with percentage or absolute numbers. Defining an offset to the result set. If we want to exclude certain number of ranks before getting into the main rank, then we work on that. The last one is a dynamic partition elements I've already done. A sort column if you want to sort the data before getting it done, and generate rank column is basically used if you want another specific column for the rank values. So we use that. Result set decides if we want the top n or the bottom n. So we can select like that. So now we will see a demo on how to work with the rank nodes.
To demonstrate a rank node, we have created a view CV top titles, and here we will be adding data from another view CV books. If we see the data, here we have data related to books with price and stock values. Let's add the rank node. The purpose of a rank node is to define the top or bottom n values of a defined measure and to output these with the corresponding attributes. Let's add the view. And the required columns. If we go to the definition, we have several options here. The aggregation functions define the key computation that is to be executed, like rank, dense rank, sum, and row. The result set direction decides whether we have to get the top or bottom n values. The result set type gives the option of selecting an absolute or a percentage rank. The target value decides the number of rows to be retrieved. Like here we will select top 5. We can also get these values from an input parameter. The generate rank columns generate an extra column in the output with the rank values. The partition column decides if we want to partition the data before we have to execute the rank. And the sort column sorts the data before we do the ranking. We can add the price here. Then we can map this, add to output. The rank can be defined as a measure as well as a dimension as per the requirement. Let's see the output. If we add the price and the publisher, we see that we got the output as the top 5 publishers. Here, if we add the title, we can see the top 5 selling titles.
So this was a demo in which we saw the basic properties of a rank node, and also we saw that how we can use the rank function to get different top n values inside the same view. So with this we came to the end of today's session. Total 3 units were discussed, and We today was mostly basics about the calculation view. In the coming sessions, we will be deep diving into the details of the calculation views, different kind of modeling features, and also we will be looking at the SQL side of it, like scripted views and table functions, how to create different kind of artifacts other than calculation view also inside the business application studio. So now it's time for the third poll. I'll be launching the poll now, and it also has four questions. So this poll mostly concentrates on the last unit that we discussed related to the different kind of nodes. So please be participative, and after that we will be discussing the right answers. So I can see that 66% people have participated. Final 2 minutes if anybody else want to mark their answers. So thank you all for participating. I'm ending the poll now, and let's discuss the right answers. So the first question was, which of the following statements are correct with reference to a union node? So here we need at least one measure to measure column is required. That is incorrect. We can union even to data sets that don't have any measures. The rest are correct. The question was, you have a customer who appeared in table A and sometimes also appeared in table B. You want to select customers that only appear in one side of the table. So which of these nodes use? Here it's operation, so we will be using node. The third question was, what is the purpose of a projection node? So here we don't aggregate the data or join the data on the projection. So these are correct, but rest two are correct. And lastly was, why do you use referential join? So the purpose of a referential join is to improve the performance. So that is the right answer. So with this, we came to the end of today's session. Here today we discussed the first three units, which were introduction to business application studio, calculation views, and different nodes in calculation view. I would encourage all of you to go through the learning journey once and also to the HANA trial account. In case there are any questions, we can take it up in the Wednesday session. So this is all for today. Thank you very much for coming and participating, and I will see you all on Wednesday. Thank you.
Recording stopped.